All right, so for this, we're being asked to solve, right? So this is very similar to solving quadratics. I think we're gonna, on the last problem we did the factoring first, and then we did synthetic division. So on this one, we're gonna do synthetic division. Remember, the zeros occur at the x-intercept. So the first thing we wanna do is pull up our handy dandy calculator. Can you guys see that okay? So just go to y equals, clear out what's ever in there, okay? And then hit x raised to the third power, right? Now my calculator looks a little different. Most of you guys have this. Most of you guys have this screen, which is known as math print. So remember, if I hit y equals, you probably have something that looks like this. But I do have one or two older calculators that show it a little differently. But they mean the same thing, right? So minus 2x squared. You guys enter this into your calculator while I do mine. Minus 3x. And that's it. You don't put equals 0. You just put the stuff to the left of the equal sign. Okay. So now I'm going to hit zoom. And since we're focusing on where it crosses the x-axis and these numbers are fairly small, I'm just going to hit zoom standard, which is option number 6. So if I hit 6 right now, I got that. Now you could zoom in a little more if you want to. You don't have to. I'm going to zoom in a little more, so I'm going to hit zoom, and then I'm going to hit option 2. And see that little cursor I have? Whoops, got a little crazy there. What I like to do is I like to zoom in kind of, wherever I put that cursor, it's just going to kind of zoom in on that spot, around that spot. So if I hit enter, I kind of get this. Okay. So it doesn't matter which point I choose, but it looks like it crosses at -1, it looks like it crosses at 0, and it looks like it crosses at 3. -1, 3, whatever. So I can hit trace. So if I hit trace and I put in -1, remember when you hit trace, the calculator will go to where x equals -1 on the graph and then tell you the corresponding y. -1 works. Does that make sense? It doesn't make sense?
When I did the same thing, you said 6, right?
Yeah.
It says I have an error. Isn't that
Mine keeps like mine doesn't even let me click any other button. It shows the road.
Oh, we'll turn it off and turn it back on. Double check your equation. Were you able to graph it at all?
It just gives me an error thing.
You probably got, does it say dimension error or
It says
syntax error?
It says dim. I'm assuming that means
That's dimension. So you need to go, so watch what I do. You ready?
Yeah.
See this where it says stat plot?
Yeah.
Hit second, y equals. Are any of yours on? Is plot 1 on?
Yeah.
So go down where it says 4. If I hit option 4, it'll take you out of that and it says plots off. And then you hit enter and it'll turn off the plots. Now when you hit the graph, it'll work. Does that work? Okay. So anyways, -1 works, right? So I already have one of the solutions. X equals -1. So if I want to do, remember, I need x to the third power, I need x squared, I need x to the first power, and then I need x to the 0. And then I'm going to put my -1 here, and we just use the coefficient. So this is 1, so I put my 1 here. The coefficient of x squared is -2, so I put my -2 here. The coefficient of x is -3, so I put -3 here. Now what is my constant? What's my constant? What's the number that doesn't have an x? Is there like a plus or minus a number here? Yeah, there is. 0. So remember how I said sometimes the problems won't have something, but you have to have a placeholder for everything? In other words, x cubed minus 2x squared minus 3x plus 0 is the same as what I have up here, isn't it? So for synthetic division to work, you have to have a placeholder for every power of x. Okay? All right. I'm going to erase this. Let's do this. So what's the first step? Drop down the 1. What's negative 1 times 1? Negative 1. What's negative 1 plus negative 2? Negative 3. What's negative 1 times negative 3? Positive 3. That's 0. We still got to keep going. What's negative 1 times 0? 0 plus 0 is 0. So I have a remainder of 0. Remember to drop down the power. So I have 1x squared minus 3x plus 0x. Okay, cool. So now I have x squared minus 3x. Are we done? No. So what could be another thing I could factor out? In other words, I'm going to have to do synthetic division again. Well, what was one of the zeros that we thought it was? How about 3? Do you think 3 is one? Let's see. Hit trace. Type in 3. 3 is 1. So now I'm going to say x equals 3. And so to verify that, I'm going to do this, but I'm going to do it to this term. So I need an x squared, I need an x to the first power, and I need an x to the 0. Again, I'm going to say 1 and negative 3. So this will become 1, this becomes negative 3. And then I don't have a constant, so I have to tack on the 0. Okay? Let's do this one. Drop down the 1. What is 3 times 1? 3. What's negative 3 plus 3? 0. What's 0 times 3? 0. I have a remainder of 0. Remember, we dropped down 1 power. This is 1x plus 0. So that solution is just x. Okay. Now the other thing we could do, it looks like it crosses at 0, doesn't it? Let's double check. Hit trace, enter 0. Yeah, it does. So now I'm going to, because this is our second answer, right? So now I say 0, and I only have x to the first power and x to the 0, right? Because this is x to the first power. The coefficient of this is 1x, right? It's the 1. So I put a 1 here and a placeholder here. Drop down the 1. This times this is 0. Add those up, I get a remainder of 0. Well, what's 1 less power of x? It's just 1, right? So the answer is just 1. Now the long division doesn't matter so much. What matters is that I found, yes?
Do we not add opposites on this side?
Opposites where?
Like add the opposites, like how you change the number?
That's only when we do long division. The opposite is already in here because, well, anyways, let's write this down. So I'll come back to that after the video, and I'll give you a little bit more detailed answer. So remember, we said that if it's a third degree polynomial, you have the possibility of having 3 answers. And because we're able to divide by this, and also by this, and for each time that we did it, we had a remainder of 0, then this is a solution, this is a solution, and this is a solution. This is very effective for a really large degree polynomial. So if you have a 5th degree polynomial, you just keep repeating this. Now there's a lengthy process that you go through. Now let's do this one with just factoring. So if I say x to the 3rd power minus 2x squared minus 3x equals 0. Is there something I can factor out of all 3 terms? Well, the numbers, there's nothing in common, right? But doesn't every term have at least one x? Yeah. So I can factor out an x. So I'm going to multiply x by something. And whatever I multiply this by, so I'm going to take this and multiply by this, and multiply by this, and multiply by this, and it has to add up to this. It has to be the same as this. In other words, what do I multiply x by to get x cubed? X squared. And this is how you double check too. You go, okay, what's this times this? Oh, it's this. Okay. Now, what do I multiply x by to get negative 2x squared? Yep, negative 2x. Again, to double check, I always mentally go, okay, this times this, does it equal this? Yep. Last one, what do I multiply this by over here to get negative 3x? What do I multiply x by to get negative 3x?
3, right?
Negative 3. Yep, negative 3, right? Okay, cool. Now this is not quite completely factored. So how do I factor the quadratic? Well, I'm going to think that my quadratic could be factored this way. Probably x times x. In other words, I'm going to take this first term, which is x squared, and I'm going to take this last term and put negative 3. Now, remember that this number here and this number here are going to be x to the 1st power, so they have to add up to negative 2x. So what are the factors of negative 3? In other words, what 2 numbers do I multiply to get negative 3? Well, 3 is one of them, and 1 is one of them. One of these has to be negative. Either the 3 has to be negative or the 1 has to be negative. Now, how I decide what has to be negative is I know that whatever is in here plus whatever in here has to add up to negative 2. So what do you guys think? Which one should be negative? Yes? Negative 3. So if I put a negative 3 here, then negative 3 times x is negative 3x. And then x times 1 is just a positive 1x. And when you add those up, right, negative 3 plus 1 is negative 2. In other words, this whole thing becomes x minus 3 times x plus 1. And then you hit equals. Now, this is what we call prime factorization. That means it can't be factored anymore. So we set each one of these factors equal to 0. So I say x equals 0. I say x minus 3 equals 0. And x plus 1 equals 0. This one's done, right? X equals 0. I got to add 3 on both sides for this one because we got to solve for x, right? I get x equals 3. Then over here I subtract 1 from both sides. Okay. Now the beauty of this, by me showing you how to do it on the calculator, I still want you, first of all, don't hand in a test with just this stuff written down. You're only getting half credit. Don't hand in your test and just have this stuff, right? I'm going to expect to either see this stuff over here, all this stuff, or all this stuff. One or the other to get full credit. But the beauty of it is, you know what the answer is if you graph it, right? If you graph it and you look to see where the where it crosses the x-axis, you know what the answer is. Does that make sense? But I still got to see the work. Any questions on that? All right, let's do another one. I'll leave that up there. I see some of you are still writing some stuff.